Ooh, focus button. Okay. So, I had the idea to do a parody of the way Hunter talks when he does his videos, but I'm not that good at impressions, so I can't do it. Darn. I think that's the universe's loss. It would have been really cool. So today we're going to talk about the chain rule. And the chain rule is used in conjunction with the product and the quotient rule. And apparently it's a way of simplifying the process of taking the derivative of two functions that are sort of stuck together, and that one can be simpler than the other, but you still have to take the derivative of both. And so say function f, is simpler than g to take the derivative of, you still have to take the derivative of g, but you can put off taking the derivative of g a little bit. And that's it, really. It's lots of people complain about it, but when you learn it, it's actually really simple. And so it's a tool used. It's not like an end in itself. It's the means to an end, rather. And so, yeah. And so U is the letter that I learned to stand for, as a little symbol, to stand for what you're not going to solve yet. And so you can put any symbol you want. It's just that I learned it as U, and my partner, who was the one who did the writing, she was in my class, and so she uses U as well. So it's written down as U, but really whenever you use a chain rule, you can put any symbol that you particularly like. Like, you could literally just draw a little snowman, and that could be your symbol. Like, that's not going to affect. It could actually make it more fun. It's not going to hurt the way that you do the chain rule. I advise you to draw something adorable, or just use any little symbol you want to make it more interesting for your professor, so that on exams, at least they get like a bit of a break. They see something amusing, a little snowman. I like the Greek letter mu, which is like the two little waves. All the cute little things. You can do anything you want. Make math more fun. It's not bad. Just, it's a bit dry. So just add a little butter, a little jam, whatever you want. And so, what was I saying? And so, I don't particularly like U, particularly because I think that it confuses. The first time I saw it, I was confused with U substitution. This isn't U substitution. I want you to understand that, because that was the first question I asked when I saw the U. So that is why you should put any other symbol you want, so that you don't get confused either. And so, ignore my cat using the litter box. And so, U stands for, in this case, whatever you are putting off finding the derivative of. And so, the equation is U is equal to radical 1 minus x. 1 minus x. Right. So my partner who did the writing, the way that she wrote it down isn't the way that you have to solve it. Your professor is going to take points off if you don't solve for the U first or whatever. As long as you understand the rule and you use the rule correctly to solve the problem, like that's the only issue that they worry about or whatever. It's all right. Where am I? So these are it's two separate bits really. It's the equation and it's U, which you then have to plug in. And so, where are we? So this is a radical, and so you understand, I should hope, that a radical is really whatever is under the radical to the 1/2 power. And so there's the way of stating things in the mathematical world, which I like, which is let this equal to the other. And so my friend doesn't do that, but it's sort of, I would say it as let x equal what's under the let U equal what's under the radical, right? And so you can solve that later. You don't have to find the derivative of U immediately. So you could just leave that there. You can just go to how to write it, which is 1/2. You're taking the derivative of the square root. And so because that's the U, you're not solving for what's under the radical. But the way that you do it is, the way that, the chain rule lets you cheat, as Hunter likes to say, is, you do that. You do 1/2, because you're bringing down the 1/2 that's really here. you're bringing down the 1/2, you're putting the u, and then you put the negative 1/2. And so there's u prime, which is the derivative of u. And so then you can solve for u prime and work it all out, because u is, you have to write in what u is, of course, in the final answer. And so you write in what u stands for, and then you put in u prime. It's really simple. That's why I'm sort of here like, what am I doing? Sort of pointing to everything, because it's worked out, but also because this is a very simple, way of showing it to you. This is a very simple example, and so it is as it is, sort of. So in this, the problem is y is equal to the square root of x cubed plus 1. So remember, even though this is a cubed and whatnot, anything under the radical is this the radical of anything is this anything to the 1/2 power. And so you could just put that down immediately, which is, you could work out what u is immediately. Just write that down so you don't get confused. And then you could take the derivative, or you could leave that till later. That's not the issue. The issue is writing out the, what's the word? The sort of, not manuscript, but the first draft of, what the final answer is going to be. You have to write it all out, write it as it is. You have to take the derivative. That's it. You take the derivative. You're taking the derivative, right? And so you take the derivative of anything to the 1/2, which is you bring the 1/2 down, and then you put to the negative 1/2, because that's how you take a derivative. And so you're letting u stand in, but of course, as Hunter says, you have to pay the price, and so you have to, at the end, derive u. And so then you put in what u stands for, which is, of course, x cubed plus 1. And then we've seen that my friend has already solved for u prime. Or you could just solve for u prime here. As you're writing it out, you could solve for u prime here. But then you have to write in u prime. And so you just have to plug in, u and u prime. And so you could solve for u prime whenever you want. So as we had a few more simpler problems worked out, but that would just, you've already seen how the chain rule works, and so seeing 3 and 4 wouldn't help you, so we were just skipping ahead to what we've labeled as 5, which is really 3, but we're not going to rewrite it just to write 3 in for 5. And so, this is going to be the third and final problem, so I won't bother you much longer. And so, one second. There we go. And so, in this, so literally, we just went to, when you really have to use a chain rule, when you have this sort of problem, which is very fun indeed. This is, sorry, I just did something weird with the focus button. I see. Okay. Oh, for the love of God. Alright, I just learned something. We're going to ignore that and move on. And so in here, y is equal to 2 cubed, and then the 3 is to the power of x squared. So it's 2 to the power of 3, 3 to the power of 2 to the power of 3, 3 to the power of x, x to the power of 2. Right. So let's just go through. So this is when what was simple when in the earlier problems, now you have to do that same thing several times over. So it's not like it's more complicated, it's just, as Hunter says, more bookkeeping. And so you have to be very worried about details. You have to make sure that you've copied it right every single time, because it's several steps this time. And so, to start with, u is now equal to 3 to the x to the 2. And so, where are we? And so now you can just write in this. You take the derivative of the equation, which is 2 to the u power, and then you take natural log. I forget why. Right, and so I thought about it. I didn't look it up, but natural log is to do with e, and so remember how e is just such a wonderful epic number. It should really be sort of just e for epic. It just, even if you take the derivative of e to anything, it still stays e to anything. It doesn't change, because that's just how epic e is. It's something to do, it's literally like, it's called natural because it doesn't change. And so you don't need to worry about it, as opposed to if you had to do a different sort of log, you'd have to worry about, base and everything. And so you don't need to worry about that with natural log. So that's why we're using natural log as opposed to, any other log. Or like, assigning a log or something. So that was a little sidetrack just for your bemusement right there. Hope it didn't confuse you any further. Just assume that you have to rather know the fact that you have to take natural log. Don't worry about any other logs. Don't worry about any other logs. Why did I do that to you? I'm sorry. So 2 to the u, we're taking the derivative of the equation. 2 to the u, and then you take, to bring everything else down, that's why we're taking the natural log, is to bring everything else down, which in this case is 3 to the x to the 2. Bringing that down because 2 is the base. And so that 2 is the base, and so the natural log of the base. And then you get the rest, which is, in this case, u prime. So remember, in this step, u is equal to 3 to the x to the 2. And so you have to take the derivative of x to the 2. 3 is now the base. And so in finding the derivative, you take natural log of the base, which in this case is now 3, and you label what's the exponent. Well, rather, what is, in this case, x to the 2. You now label that z, which you will now have to find the derivative of, which will now be z prime. And so the new step is you have to take the derivative, what you write it, because remember you have to plug everything in. So you plug in u prime, which is what I just showed you. And so now it's 2 to the u, ln of 2, u, the original u, ln, natural log, of 3 of z prime. Now let z prime be x squared. You now have to find the derivative of z squared, which is, z prime, which is now 2x. So it's now, you don't have to be worrying any further. So like if you could go endlessly, literally, that's the point of, I suppose that's what confuses lots of students, is that you can just go on and on and on doing exponents of exponents of exponents. But in this case, it's just 3. So the steps just go on. You just have to keep bringing the exponents down until you're finally done. And so when you're finally done is when it's like you start to recognize, is when you recognize what the derivative, you recognize the derivative as something that you've seen before, rather. You don't have to solve any further. And so you have to plug everything in, of course. And so the final answer is that u prime is equal to u. Remember that u is 3 to the original u is 3 to the x to the 2. Take natural log of 2 to bring down everything else, because 2 is the base. Bring down everything else. And so the second u was then 3 to the x to the 2. And so to bring 3 down, you have to take natural log of 3. And then you take the derivative of x squared, which is in this case 2x. And that is it. And have a very nice day. Or night, whatever time it is. I hope you're not doing this right before an exam. Have lots of fun. So, to you, the viewer, because, the viewer could be not Hunter, I hope you have a very nice life, and I hope that this has helped you. I'm not sure if it has, but I pray that this hasn't confused you further. My partner's done a great job writing everything out. I hope I've done a good job pointing things out and explaining it. And seriously, bye.